You are alive. Last presentation is by John Hughes, and John has been working with me on how GPS data can be used to do some sort of identification of seismic activities. So this is just, yeah. Yep, that's the pusher.
Okay, my name is John Hughes. I've been working on using global position data to find a possible correlation with seismic activity. Next slide. As we all know, GPS data is used to estimate someone's position on Earth. We also know that it's also used to estimate total electron content, which is TEC, and total electron content is the number of free electrons between the receiver and the satellite. And the picture that you see right there, it's not in color though, but the two squiggly lines represent the ionosphere. The dots represent the free electrons, and the cylinder sort of represents the disk, like the straight line between receiver and satellite. So, and there's that equation. It's actually like integral between the line. Okay. So GPS data is corrupted by various errors. There are errors due to the clock errors from the receiver, and clock errors from the satellite, and also from the atmosphere being 3 space, which right there's the orbit of the satellite. That is pseudo range 2. So basically, the free electrons, the cylinder represents the pseudo range, which is the distance between the receiver and the satellite. The clock, the two different orbits are basically, one orbit is false while the other one's true because of these errors. The clock errors from the satellite are basically due to the receiver and the satellite not having the same atomic clock. The receiver errors are due to the fact that the receiver can overheat, and the time errors from the atmosphere is because the ionosphere isn't like a vacuum. It has electrons on its side. So it's very difficult to remove the errors from a GPS system. Only 2 groups have been successful at it, MIT Haystack and Jet Propulsion Laboratory. And there's also a group in China that's also done the same thing. And so basically, for my project, I had to use 3 types of files. They're basically Linux files, SP3 files, and IONIX files. Linux files contains the pseudo-range measurements for the GPS system. It also carries the L1 and L2 carrier phase measurements, and the PRN is basically the pseudo-random noise for a satellite in one constellation. So basically, SP3 files just contain the satellite orbit information, while IONIX files contain the known errors in the IONIX files. And so these are the 2 equations that I use. So you notice that as F1 and F2, those are basically 2 different frequencies in the GPS. The DCBI and the DCJ is basically the receiver and satellite errors. And yeah. So basically, these are the types of earthquakes that experience: divergent, convergent, and transform. You notice that they actually move apart toward each other and up. and part of each other. So this is some information about the Japan earthquake that I actually used. It's called the Tohoku earthquake. It occurred on 2:46 p.m. Japan Standard Time on Friday. The center, it's located between the Pacific and North American plate. It's also a convergent earthquake. So yeah. So what's happening is what you'll see that when the plates actually move, the electrons actually go to the ionosphere and they go together. And peace. So this is basically my block diagram. Basically, I go to GPS acquisition, then I remove the errors from GPS system, then I convert that into total electron content, and then I display the results. So basically, this is a map of the receiver locations in Europe. I had to use sites in Europe to test the code that I used to remove all the errors. You'll notice that I've circled the site called graphs because I use that. I graphed the total electron content for that site. And you'll notice that it doesn't have any disturbances along its parallel shape at all. Then I used Japan sites. You'll notice that the blue dots are all the receiver locations in Japan, while the red dots are basically the receivers that I used to remove all the errors GPS system. On the graph to your right, you'll notice that it actually had little disturbances along parallel shape. Down here's the movie that I have. You'll notice that the color bar has total electron content to the side, while it has azimuths and elevation angle. And you notice that as the time increases, that it changes color. It goes from yellow to red to blue. Blue is after the earthquake, and red is like getting close to the earthquake, which you'll notice that it has time until the earthquake, and it has the time for Japan Standard Time. And yeah. Had enough of that. So conclusion, we basically know that the fluctuations in the TEC, that as the earthquake approaches right after the earthquake, we know that based on the knowledge of our ionosphere, TEC fluctuations you'll see originate from another source. Our current claim is that TEC fluctuations are due to seismic activity, And as we become more knowledgeable of interpreting these fluctuations, it will be possible to develop an earthquake forecasting system. And we plan to, in the future, to compute the electron density directly from the TEC. And that's it. So any questions?
Let's go back to that. I think you lost your audience here.
I lost my audience.
What John is showing, that's
Oh.
not only the blue dot on the right-hand side here is the epicenter of the earthquake, and this blob that we see in the middle is how the electrons are varying as a function of time. So there's a timekeeper that's saying what happened, how long before the earthquake is shown this, about 490 seconds. So where is a lot of electrons, in the middle we have purple, that's lesser, and then you have magenta and blue, which mean almost no electron. And what you will see is as the earthquake approaches, particularly right around this epicenter, you're going to see this sudden drop from red to blue. And that sudden drop from red to blue is not physically realizable. You cannot have this in a normal ionosphere. So right there you start seeing you're like a minute before the earthquake, and you're way up there in 55 regions, and then all of a sudden, right after the earthquake, you're going to start seeing that sudden drop from a whole lot of electrons to no electrons. So that's the key of the message, that this kind of behavior right there, right now, which is right facing this this epicenter, could not have happened unless something caused it. There's no way in the world you could have this sudden drop from red to blue, right facing the epicenter, unless something caused it. That's the key message of his work. All right,
Yes, there's no questions.
any questions for John? Right then, so that's the end of our second session. So we're going to take a break now, which we probably all need, and we'll return around 4 o'clock for the last session.